Everyone, welcome back. We are continuing the lesson on graphing. We will do one more complete example, and then we will also take a look at the concept of finding an absolute maximum, absolute minimum on a graph. So for this example, we are given f of x equals 7x to the 6 minus 2x to the 5. And as you can see on the right hand side, we're going to do the complete analysis for this one, including increasing, decreasing intervals, concavity, as well as relative max, min, and inflection points. Okay, so we learned from the last few segments that to get information about increasing, decreasing nature of the graph or relative max or min, we need to take the first derivative and set it equal to 0. So we do it for this function. So we get 42x to the 5 minus 10x to the 4. And we set that equal to 0 to solve for our x. Notice that we can take out 2 times x to the 4 from both of these. So take out 2 times x to the 4. You will have 21x from the first piece and 5, just a 5 from the second piece. And if you set each one separately equal to 0, this first part will give you 0, x equals 0. The second part will give you, if you said 21x minus 5 equal to 0, x is 5 over 21, or 0.24 to be exact. So we put them on the number line from the smallest to the largest. So 0 on the left, 0.24 on the right, and we pick test values from in between those critical points. So I can pick -1, 0.1, and 1 as my critical test values rather. And we're going to plug them into f prime because we want to see the sign of f prime over those 3 intervals. So you can do this, plug them into the factored form of f prime, remembering that the first portion, x to the 4, is always positive. You really only need to plug them into the second portion, 21x minus 5. So if you plug in a -1 in there, you're going to get a negative. If you plug in a 0.1 in there, our test value from in between, that will also be a negative because you're going to have 2.1 minus 5, which is negative. And then plug in a 1 in there, you get a positive. So the sign charts are negative, negative, and positive, which tells us that the graph is falling all the way to 5 over 21 and rising afterwards. So the graph is falling up to here and rising afterwards. So 5 over 21 appears to be a relative minimum. So now we can also fill in the blanks here. So we found the critical points. The intervals of increase is 5 over 21 to infinity. Intervals of decrease is -infinity to 5 over 21. And there's no local maximum, but there's a local minimum at 5 over 21. Okay, now we need the analysis for f double prime. So this time, take the second derivative of the function. I would take it right from this point here and take one more time the derivative. So here we're going to have 5 times 42, or 210 x to the 4 minus 40 x to the 3rd, and set that equal to 0 to find the candidates for the inflection points. And notice that we can take out, looks like we can take out a 10 from both of these, and also x to the 3rd. So 10x to the 3rd times, from the first part, there's 21x remaining. From the second part, if you take the 10, you have a 4. X cubed is already gone, right? It'll be minus 4. When you set the whole factored form equal to 0, now you can set each factor separately equal to 0. If 10x to the 3rd is 0, you can divide both sides by 10. So x to the 3rd is 0, and cube root of 0 is 0, so x will be 0. If 21x minus 4 is set equal to 0, 21x equals to 4, x is 4 over 21, roughly 0.19. And so we put those two numbers on the number line, and this time we want to explore the sign chart for f double prime. So again, pick a point from here, one from there, one from there, from each of those 3 intervals. And this time plug them into your f double prime equation. Like if you take a negative, -1, for example. Right, something selected to the left of 0, such as -1. If you plug in there, you're going to get negative times another negative the end result will be positive. So you can do this for the other values as well. So please confirm that the sign chart for f double prime will reveal a positive in the first interval, a negative in the middle interval, and a positive in the last interval. So no arrow signs, right? This indicates concavity. So we're saying concave up, concave down, and concave up. So we can fill in the blanks. Where is the concave up? In two intervals, right? Negative infinity to 0, but also from 4/21 to infinity. Where is the concave down? In the middle, from 0 to 4/21. And what are the inflection points? These two, because concavity changed across them, 0 and 4/21. And if there need be, we can substitute them into the original function to get the y coordinates. All right, so that completes the analysis for this problem, but there's something very interesting to do here, and that is to take actually a look at the original graph, okay? So I want to take a look at that. So 7x to the 6 minus 2x to the 5, I actually went to desmos.com. And if you actually graph it first, 7x to the 6 minus 2x to the 5, in a regular standard viewing rectangle from negative 10 to 10 on the x and the y, it looks like a simple U-shaped curve. And it looks like what we found on the other page with concavity doesn't seem so true. Like how in the world does it have a region when it's concave down, right? Because if you look at our information here, it decreases up to a point and then it increases. But it's supposed to be concave up and then down and then up again. So we don't see that right away, right? But I went in and zoomed in into this graph right around there. I zoomed in a lot. And this is what I found. You see, like I'm going from only from negative 0.0005 to positive 0.0005. That's how much I zoomed in. And now all of a sudden you see a hidden characteristic of this curve revealed. And calculus could help us notice that without having to zoom in so many times, right? So we know that it's concave up to a point, then concave down up to a point, and then up again. And only then we get the true characteristics of this function. Okay, so with that, I have an interesting question, and then we're going to do absolute maximums and minimums. And the interesting question is, suppose I give you some information about f prime and f double prime. Can you figure out the graph with no other information other than f prime and f double prime sign chart? So I will do the first one. I'm going to ask you to do the next two. So if f prime is positive over 0 and f double prime is negative positive, what kind of a rough graph would this be? Remember, f prime tells you it's rising or falling. Here it's rising everywhere. So through 0, it will be rising. And of course, there are different versions of the answer. We're just looking for the general rough sketch. Okay, with concavity, it should be concave down first and concave up next. So as it's rising, it should be concave down and then concave up. So there is your general shape of this graph. Now, can you use similar ideas to do the next one? All right, so hope you gave it some thought. You pause the video. This time it's decreasing and then increasing. So roughly speaking, graph will be decreasing up to 0, increasing afterwards. Of course, it could be like over here, but again, answers could vary, but general shape should be the same. And the concavity is concave up and concave up everywhere. So this is just going to be your typical U-shaped curve. It's concave up everywhere, following the pattern of falling and then rising. Okay, could you do it for this one? Okay, so hopefully you gave it a try. Spoiler alert, if you haven't, go ahead and stop the video and please come back to look at your solution. This one is decreasing everywhere. And it's first concave up and then concave down. So concave up, it has to follow the general pattern. First is concave up, just a subtle concavity change. The concave up and then concave down while it's going. I think I should use a different color there. All right, so it's falling everywhere, but first concave up and then concave down. There we have it. All right, and last, we will take a look at determining or finding out about absolute maximum and absolute minimum points on a graph. So once again, what are those points? Those are the absolute highest and absolute lowest points. For example, this point here is locally a high point. It's a relative max or local max, but it's not the absolute max. The absolute max of this graph is this point right here, and absolute minimum is this point right here, absolutely the lowest point on the graph. And typically the way they're going to ask you this question is, they're going to say, find the absolute max and min of a function over a closed interval. So they will give you the interval. And there is a theorem in mathematics that states that over a closed interval, you are guaranteed to find absolute maximum and absolute minimum. And to find absolute max and min, we're going to begin the same way. Set f prime equal to 0 and find, well, f prime is 0 or f prime is undefined. But then you will also look at the endpoints of the interval. So this is going from A to E. So in addition to local max and local minimums, or the critical points, you should also take your endpoints such as A and E and substitute everything into the original function. So you're going to evaluate the original function at the critical points as well as at the endpoints, because an absolute max or min can occur at an endpoint or it can occur at a critical point. So you want to consider all of those options, and then the highest f of x value is your absolute max, the lowest f of x value is your absolute minimum. So for instance, let's take a look at this example. Okay. So we have f of x equals x squared over the interval from -1 to 3. So we begin by locating the critical points by setting f prime equal to 0. So in part A, f prime of x is equal to 2x. Set that equal to 0, we get x is equal to 0. Now remember, you need to take the critical points as well as the endpoints of your interval, and I like to put them from the lowest to the highest, and I like to put first the endpoints of the interval in here, because I can only use the critical points that fall in this interval. Like if I got x equals to 4 here, I couldn't use it because I'm trying to find the absolute maximum within this interval. So 0 falls in between, so that's okay to use. Now each one of these values, go ahead and plug into the original function. Since it's the squaring function, you get a 1 here, a 0 there, a 9 there. And look at now the highest point, the absolute largest number under the f of x column. That is your absolute maximum. And the lowest point in that column, that is your absolute minimum. And if you were to check out the graph for this, we're looking at the x squared function from -1 to 3. So this one corresponds to 9. So that's your absolute highest point, 3, 9, and your absolute lowest point is going to be right here, 0, 0. So absolute max is 0, 0, absolute min is 3, 9. Excuse me, the other way around, right? 0, 0 is your absolute min, and 3, 9 is absolute max. And sometimes they will ask you just for the y values. They'll say, what is the value of the absolute maximum? So then you would only enter the 9, okay, if they ask you for the value. For my test questions, typically I'm going to ask for x, y, but be aware that's another way to ask the question. So let's go through these last two examples together. So f of x equals x to the third minus 12x over the interval from 0 to 4. We want to find the absolute maximum and absolute minimum. So begin by locating the critical points that lie within the interval. So I'll give you a moment to set this one up. So hopefully you gave it a try. And now let's take a look at the solution. So take the derivative, 3x squared minus 12, set equal to 0. To solve this, I can subtract 12 and divide by 4. So x squared is 12 over 3 or 4. So 3x squared is 12, x squared is 4. X is plus or minus 2. But of those two answers, only the positive 2 lies in this interval. So I can only take the positive 2. So I will put 0, 2, and 4 in my chart. plug each one into your f of x function, the original function, because we want to see the y coordinates along the graph, which one is the highest, which one is the lowest, right? That's why we're plugging them into f of x. If you plug in a 0, you'll have 0 minus 0, you get 0 back. Plug in a 2, you're going to have 8 minus 24, or negative 16, and plug in a 4, you're going to have 64 minus 48, or 16. Of those, look at the y coordinates. This is the absolute lowest, and this is the absolute highest. So those are your absolute min and absolute max, respectively. 2 comma negative 16 is your absolute min. 4 comma 16 is your absolute max. So one more question. Please apply the same technique to find absolute max and min for this question. Again, please take a moment and come back to view the solution. Okay, so hopefully you gave it a try. And here we go. So take the derivative. By bringing the 4 down, the 4's will cancel. You'll have 3x to the third. Bring the 2 down, the 2's cancel. You have minus 3x. And derivative of 20 is 0. So 3x squared minus 3x. We set the derivative equal to 0 to locate the critical points. So for this one, you could factor out a 3x, right? Take out a 3x, and you will be left with x squared minus 1. You could further factor this if you like. You know, there's multiple ways to go about it, but you could factor this as x minus 1, x plus 1 also. So basically there's 3 solutions: x equals 0, x equals 1, and x equals negative 1. So again, depending on how you solve it, but ultimately, can we use all 3 of those, or only some of them are eligible? Let's see, which ones of those lie in the interval between negative 3 and 0? Okay, 0 lies in there. It's also an endpoint, right? Negative 1 lies in there, but not positive 1, right? So we need to exclude positive 1. So only take 0 and negative 1. So as a matter of fact, again, you may want to write the negative 3 first and put the 0 on the bottom. Those are the endpoints of the interval, and only put the critical points that lie in between. So clearly 1 is not going to be one of them, but negative 1 is. So once you've located what your critical points are, and the endpoints also go on that chart, as you know, we're going to plug each and every one of them into our f of x. This is where it would be helpful perhaps to put this into your f of x or y equals screen, and then go to the table to calculate quickly the function at these 3 values. Of course, at 0, it'll be 20, right? And then the other ones, you can get help from the calculator. So now identify the largest number there on the second column. That's your absolute max. And the lowest number there, that is your absolute minimum. So that is our answer to the question, and that's the ending of our graphing section. So as always, I would now go and solve lots and lots of questions, and that's the only way to truly understand the lesson. See you next time.